Hello, today I will discuss the topic the transfer of force to a new parallel position. Okay, so let's consider a rigid body. Okay, this is the rigid body, and this is point A, and a force of magnitude F is acting at point A of this body, and another point, we consider another point B here on this body, which is distance D is away from point A, or we can say that the perpendicular distance from point A to point B is D. Now if you want to transfer this force which is acting at point A to point B, then what is the mechanism? Okay, so again same rigid body, point A is here, force is acting here. Okay, this is the line of action of this force, and this is point B. The distance between A and B is D. Okay, this is the perpendicular distance. Now we want to transfer this force from point A to point B. Then what we can do? So if I apply two forces with same magnitude which is acting at point A to point B. Okay, so first we apply two same magnitude forces to same magnitude opposite forces at point B. So net force at B is 0. Okay, so it means there is a no change to this object by introducing these two forces at point B. Okay, so now my situation is, this is point A where force F is acting, it's the line of action of the force, and this is point B where I apply two same magnitude forces in opposite direction, and the distance, the perpendicular distance between point A and point B is D. So if we look at this figure carefully, then what we will observe, so this force which is acting at A and this force which is acting at B will form a couple. Okay, so point A is here and force is acting here at point A, and the distance, the perpendicular distance between both forces is D, and this force acting at B will form a couple. Okay, so this is nothing but a couple, and moment of couple M is equal to force into D, and the tendency of this couple to rotate the body is in direction. Okay, so we can say the direction is clockwise for this moment. Okay, and we can also represent this couple. So any couple, and this is the couple acting at, okay, the distance between the couple is D, so we can also represent by the direction. So this is the, you can write a couple of magnitude M, that is the F into D. Okay, so whenever we see either a sign of this clockwise or anti-clockwise, it means a moment of couple is acting on the body. Okay, so now the situation, if we look at after this, what we'll notice on body, okay, so this is again body, okay, the point A is here, and this is now point B. Okay, so one force is acting at point B, and we can represent the moment here M, the magnitude is F into D. Okay, so we can conclude that, so shifting of a force is possible with a couple. Okay, it means we can transfer any force acting at point on body to a new parallel position on this body by using the moment. So now if we calculate what is the moment of the force which was acting on the body, and what is the moment of couple. So moment of force, okay, about point B, Okay, let's say the image 1. Okay, this is as per image 1. Then moment about point B is equal to force acting at A, and then distance between force, the perpendicular distance between the force and the point or the line passing through this point B. And if you look at the direction, then this force has a tendency to rotate the body this direction. Okay, so this is the clockwise, and the direction is the clockwise. Okay, so this is the moment of force about point B. After shifting, force from A to B, then the moment of couple will be the force into perpendicular distance between the parallel forces. Okay, so this is the D, force magnitude is F, so the moment of couple is F into D, and the direction is also, okay, so this couple has tendency to rotate the body in clockwise, so is this one. Okay, so this implies that the MB is equal to the moment of couple. So we can estimate the magnitude of the couple by finding the value of moments of given force about the point where we want to shift this force. Okay, so this is the so now we can also conclude that the moment of this force, okay, about this point, because moment of the force, so we can also say that initial moment equal to final moment, because so initial moment is mb about point B, okay, then final is moment of couple, and then moment of force about B, and this is the 0. Okay, and this is after shifting, because this force is passing through the point B, so the net moment of this force is 0. That's why the moment of body, initial moment, and now the final moment. Okay, so there is no change in moment. Okay, so no change in magnitude as well as direction of moments during or we can say that during directional moments when the force is shifted to a new position, a new parallel position. Okay, so this is the way to transfer a force from one position to another parallel position with the help of the moment of a couple. It means the force at a new position. Okay, so we can transfer the one force from point A to point B by one couple and a force acting at point B. So now let's prove this statement that MB is equal to M, or we can transfer a force acting on any rigid body at a given point to a new positions with force and moment of couple. Okay, so let's consider a simple example. So if I consider a body, okay, let's say this is object and this is point O and this is point B. And one force is acting here at point B of 500 Newton. And the distance between the both points, point O and point B, is 3 meter. Okay, so force at B, value of the force is 500 Newton, and the distance between B and O is 3 meter. Okay, now if you want to shift this force 500 Newton to point A, okay, so shift 500 Newton from B to point O, okay, because both are the parallel points, or we can say the line passing through both points will be parallel lines. So now I can, the first step is that okay, this is point B, the force is acting here, okay, so 500 Newton is there. Now I will introduce two same magnitude force but in opposite direction at point O. This is point O and distance is 3 meter. Okay, so I will introduce two forces at this point, 500 Newton, and this is also 500 Newton at this point O. Okay, so net sum of these forces will be 0, so there is no influence or there is no additional change to this body due to uh, both forces. Okay, so now this force, okay, this 500 Newton force acting at point O, and this is the 3-meter distance, and this is the point B here. Okay, and the same force of 500 Newton. So this is nothing but a couple. Okay, and the moment of this couple is 500 into 3 means 1500 Newton meter, magnitude of this, and the direction, because the tendency is to rotate the body in this direction. Okay, so the direction is anti-clockwise. So now the problem will transform, or now we can say that this point O is here and this is point B. Now this force and this force, they already form a couple. So we have the force, remaining force, we have the remaining force here 500 Newton, and the couple of, okay, so this is couple of M is 1500 Newton meter. Okay, so in this way we can transfer any force into a force and a moment of couple. Okay, so initially we the force was at point B, and after introducing two forces in opposite direction at point O, and a couple will, this one force at point B and one force at point O will form a couple. So the magnitude of couple is 500 Newton and the direction is in anti-clockwise. Okay, so and then we can write the problem will reduce, or the problem will be, the situation will be now look similar to what we discuss in theory. Okay, so one force and one the moment of couple acting at point B. Okay, so we can transfer already. Okay, so we already transfer force from B to point A. So the moment of the force, okay, moment of this force which was acting at point B about O. Okay, so moment of the force about O, MO, is nothing but the 1500 Newton meter, and then tendency of this force is also in anti-clockwise. Okay, so tendency is also in anti-clockwise, tendency to rotate the body anti-clockwise. Okay, so this is again the anti-clockwise, sorry. Okay, so okay, so this is anti-clockwise, and the moment of couple is also 1500 Newton meter. Okay, and also in the clockwise. That is fine. Okay, so this is the anti-clockwise again. So this is the initial moment of forces acting on the body, and this is the final moment of acting on body. It means the final moment is due to the couple and the initial moment is due to the forces. So there is a no change in the moment acting on this body. Okay, similarly we can take another example. Okay, so let's say another example. So we have any object. Okay, and one force is acting. This is point A and this is point B here. One force is acting here. Let's say the magnitude force is the 600 Newton, or let's say the 60 Newton. The distance between both point is D is the 4 meter. Now if you want to transfer this force of 60 Newton to point B, then okay, so this is the 60 Newton. So we introduce two forces of 60 newtons in opposite direction at point B, and this force and this force, okay, they will form a couple. So then the problem will be now this one, and the couple will form, couple is this one. Okay, so the magnitude of moment of couple, so this is the 60 Newton and distance is 4 meter, and this is 60 Newton. Okay, so this is the couple. So moment of couple is 60 into 4, so 240 Newton meter. And the direction, the tendency of this couple to rotate the body in this direction. Okay, so this is clockwise, so we can write direction is clockwise. So therefore okay, so we can mention couple here M equal to 240 Newton meter. Okay, so we can transfer this force which is acting at point A to point B with a couple of moment of couple. Okay, so this was the concept to shift the force which is acting on a rigid body to a new position which is the parallel to the initial position with the help of the moment of couple. Thank you.